Hello class. Ready for another adventure in learning? Let's jump right into today's lesson. In our last lesson, we explored degree of accuracy. In today's lesson we will move on to a related concept, percentage error. Let's dive into understanding how to calculate and interpret this concept. Percentage error is a way to measure how far your estimated or measured value is from the actual value expressed as a percentage. No measurement, however carefully made, is exact. All measurements are approximate. For example, if the width of a room is measured as 2.8 meters to two significant figures, the actual width may lie between 2.75 meters and 2.85 meters. The error of this measurement is 2.75 meters to 2.8 meters, or 2.85 meters to 2.8 meters. That is, 2.75 meters to 2.8 meters is minus 0.05 meters, or 2.85 meters to 2.8 meters gives us plus 0.05 meters. To better visualize this, the diagram below illustrates the range of the actual measurement. Before we move on to solving this example, let's first state the formula for calculating percentage error. To solve for a percentage error, we use the formula. Percentage error equals error divided by actual measurement multiplied by 100. Alternatively, the formula can be written as percentage error equals AM minus WM divided by AM multiplied by 100, where error is the difference between the actual measurement and the wrong measurement. That is, AM minus WM. AM stands for actual measurement. WM stands for wrong measurement. Both formulas are equivalent, and you can use either, depending on the values given in the question. Now, let's solve for the percentage error of the example from the previous slide. To solve this example, let's bring back the diagram we used earlier to illustrate the range of measurements. We'll be using the first formula for percentage error. Recall that we already determined the error to be plus or minus 0.05 meters. Actual measurement equals 2.8 meters. Now, substituting into the formula, percentage error equals plus or minus 0.05 divided by 2.8 multiplied by 100. Applying the BODMAS rule, we will start with the division. 0.05 divided by 2.8. Use your calculator to solve for this. The result is plus or minus 0.0178571. Next, we multiply the result by 100. The answer is plus or minus 1.78571%. Rounding off to two significant figures, our answer is equal to plus or minus 1.8%. Refer to Lesson 8 for a recap on rounding to significant figures if needed. Let us look at another example to enhance our understanding. Example 2. The percentage error made in measuring the length of the side of a classroom is 1.2%. If a student measures the classroom length to be 3.5 meters, what is the actual classroom length? Solution. To solve this, we will use the second formula, because we are finding the actual measurement, where percentage error equals 1.2%. The measured length, which is the wrong measurement, equals 3.5 meters. The actual measurement is the value we are solving for. Let's represent the actual measurement with the letter X. Now we will substitute the given values into the formula. The percentage error is 1.2 equals actual measurement is X, subtracted from the wrong measurement, which is 3.5, divided by the actual measurement, X, multiplied by 100. Let's simplify this equation by cross-multiplying. This gives us 1.2 multiplied by X is 1.2x, equals X minus 3.5, multiplied by 100. Now, we will expand this equation by applying the distributive property of multiplication, which states that multiplying a number by a sum or difference is the same as multiplying that number by each term in the sum or difference, and then adding or subtracting the results. 1.2x equals 100 multiplied by x is 100x. 100 multiplied by minus 3.5 is minus 350. Let's rearrange to collect like terms together. Note that, when a term crosses the equal sign, its sign changes. This is called transposing terms. So, when we bring 100x to the left-hand side, we have 1.2x minus 100x equals minus 350. 1.2x minus 100x is minus 98.8x equals minus 350. To isolate x, we divide both sides of the equation by the coefficient of x, which is minus 98.8. This gives us minus 98.8x divided by minus 98.8 equals minus 350 divided by minus 98.8. For the left-hand side, minus 98.8x divided by minus 98.8 gives us x. Let's now solve the right-hand side in order to get the value of x. Minus 350 divided by minus 98.8. Recall the rule of signs. Dividing two negative numbers gives a positive result. Using a calculator, 350 divided by 98.8 is 3.54251. Rounding off to two significant figures, our answer is 3.54 meters. Therefore, the actual classroom length is equal to 3.54 meters. Assignment. Write down the assignment below and try solving them yourself. Calculate the following. Take your time to walk through these questions carefully. In conclusion, we have learned how to calculate percentage error in measurements. In our next lesson, we will be exploring a new topic, which is sequence. Congratulations on completing this lesson. You should be proud of yourself. Thanks, and goodbye.